Now we consider reflection phenomenon, okay, using wave theory. In that, first one is law of reflection. We know that law of reflection is angle of incidence is equal to angle of reflection. This is I. What is actually angle of incidence? It is the angle between incident ray and the normal. In ray picture I am saying, okay. Angle of reflection means what? Angle between the reflected ray and the normal. This you might have studied even in ray optics. Now we will prove this I is equal to R using wave picture. In wave optics we will see how to give the proof for that. For that, obviously we should draw the diagram. This is the diagram for law of reflection. Plane wavefront reflected from a plane surface. This Mn, you know, that is reflecting plane. Mn reflecting plane, okay, reflecting plane. Or you can even say that it is plane mirror, okay. This one, you know, 1 and 2, the straight lines, they indicate incident rays. So I just write here 1 and 2 incident rays. Incident rays. And then AB is incident wavefront. It is indicated here. AB is incident wavefront. We know that ray should be perpendicular to wavefront. You see, this is 90 here. Okay. This symbol will indicate 90 degree. This also will be obviously 90. So ray and wavefront make an angle of 90 degree with respect to each other. Similarly, this angle is also 90. That angle is also 90. So there is no doubt between, of course, there is no doubt that 1 and 2 are incident rays. And the rays are perpendicular to the incident wavefront AB. Of course, you can say that there are a lot of points, in fact infinite points in this incident wavefront, all on this wavefront. So this point, all on this incident wavefront. If this is angle of incidence, this also will be angle of incidence. Please understand, in ray picture, angle of incidence is defined as angle between incident ray and the normal. In wave picture, angle of incidence is defined as angle between incident wavefront and the plane, reflecting plane. So we know that this is angle of incidence. If this is I, this also will be I automatically. Or if you want to have a simple proof, I just give like this. Let's say you call this angle as some some easy angle. Let's say this angle is, it's not 5 degree. Say this angle is represented as 5, this angle is 6, this angle is 7, this angle is 8, let us say. Right? So we know 5 plus 6 plus 7, 90 degree. I just write here, just change the color. Same color is boring. Okay. So 5 plus 6 plus 7 plus 5 plus 6 plus 7, 90. See, these numbers are just indicating the angles, okay. It's not, they are not the angles by themselves, okay. 5 plus 6 plus 7, 90. Angle between this ray and this wavefront. Also, because this is normal, you know, this is normal. You should not forget. So 6 plus 7 plus 8, 90. 6, 7, 8, 90, because this is normal. This one is normal, okay. So 6, 7, of course, can cancel. So 5 is equal to 8. This is 5, this is 8. So if it is angle of incidence, this is also angle of incidence. Got it? Similarly, you can prove this side also. That means CE is the reflected wavefront. So this is reflected ray. This is reflected ray. You can see this arrow. Similarly, the corresponding reflected ray will be here, but that is not shown. Okay, that is not shown, not necessary for the proof. Okay, then CE is a reflected wavefront. So how do you construct CE, which is a reflected wavefront? What you should do, the first point on the incident wavefront to be incident on the reflecting plane is A. Okay, that is A. Then what will happen? Last, this point B will come here, and then it will be incident on C. First point to be incident on the reflecting plane is A. Last point to be incident is B. So once this A is reflected here, now we will consider the wavefront at a later instant. So taking A as center and VT or CT as radius, we will have to construct circles, forward envelope. So we will construct it in the direction of the ray. For that, instead of drawing the full circle, we just draw the arc. This arc means that it means it is a secondary wavelet, all starting from A. Then common tangent plane you draw from C, common tangent plane, because a little later this point will be incident, little later this point will be incident. So you will have all the secondary wavelets starting. So you will have to draw common tangent to all the secondary wavelets. Another secondary wavelets may be here. So CE will be the reflected wavefront. Is it clear? Because by the time the waves from A reach E, the point B would have reached C. The time taken by the point B to reach C, what is this point B? It is on the incident wavefront. Let's say if it is time t, right? So if t is the time taken by the point B to reach C, then in the same time t, the secondary wavelets from A would have gone to this point. So you draw common tangent plane to all the secondary wavelets. So CE will represent the reflected wavefront. Agreed? So how to prove this? Very simple. By the time B reaches C, the point A would have reached this location E. So BC, if you take as VT, then AE is also VT. You can take V to be speed of light if you are studying optics. So BC is equal to AE. Note that we have drawn secondary wavelets. Taking A as center, VT as radius, we will have to draw full circle, or we consider the circle in the forward direction. Forward direction means the direction of this ray. We just draw an arc which is indicative of the secondary wavelet. Okay. Now consider the triangles AEC. Triangles AEC. I just corrected. Triangles AEC. Consider the triangles AEC and ABC. ABC. Right? I just remove this also. Okay. Fine. Consider the triangle AEC and ABC. Now AE equal to BC. Because by the time B reaches C, A reaches E. Speed is same because the medium is same. Light is reflected back into the same medium. So VT, VT. Right? V velocity of light. Then AC is common to both the triangles. AC is common to both the triangles. And angle ABC equal to angle AEC. Angle ABC. Angle AEC. Each equal to 90. So what can we now say? The two triangles are congruent. Triangle AEC congruent to triangle ABC. So this angle, okay, what is that angle? This angle R belonging to triangle ABC, belonging to triangle AEC. This R belongs to the triangle AEC, equal to I belonging to the triangle ABC. So I is equal to R. Hence the proof.